Okay, so we're going to talk about if-then statements. We're going to talk about the hypothesis and the conclusions of if-then statements, and we'll talk about counterexamples. So, a conditional statement can also be called an if-then statement. Those are synonymous with each other. The reason they're called if-then statements is because they start with an if and they have a then in the middle. There's a hypothesis and a conclusion, which is the next thing. The hypothesis states what we are accepting to be true. So, generally the first part of a conditional statement, we just accept it to be true. No matter how weird it sounds, that is true. And if we know that, we can then determine the truth of the conclusion. And it generally comes in the form if P then Q. And we'll talk about this. But they don't always have to be in the form of if and then. So it's why I prefer to call them conditional statements, because there's always a hypothesis and there's always a conclusion. So there's a condition. They can come in the form if P then Q. They can have P implies Q, P only if Q, or Q if P. So Q if P is the weird one, where the hypothesis and the conclusion switch, but it's still a conditional statement. So let's look at some of these. If it is raining outside, then I will keep my windows closed. In this conditional statement, the hypothesis is it is raining outside. It's whatever comes after if. It does not include if. So my hypothesis in this conditional statement is it is raining outside. So that's what we accept to be true. So I'm knowing it's raining outside. That's my hypothesis. That's what I'm going with. Then I will keep my windows closed. So my conclusion is I will keep my windows closed. It does not include then. Then is not part of the conclusion. The conclusion is strictly I will keep my windows closed. That's it. So if we say the hypothesis is underlined in purple, it is raining outside, and the conclusion is underlined in red, it would be I will keep my windows closed. If and then are part of neither the hypothesis nor the conclusion. In this statement, we are going to identify the hypothesis and the conclusion, and we'll keep the hypothesis in purple and the conclusion in red. In this case, the hypothesis, if 2x minus 1 equals 5, that's what I'm accepting to be true. If that is true, then x equals 3. This is a true statement. If I were to solve this expression, if I were to solve this equation for x, I would get that x equals 3. This is a true conditional statement. In this 8y equals 40 implies y equals 5. The hypothesis is going to be 8y equals 40, and the conclusion is y equals 5. That's a true statement. If I were to solve for y, I would get that y equals 5. The hypothesis, so rs equals 1/2 rt if s is the midpoint of segment rt. Now this one has it's the only word in here is if, and this is the weird one. So this one, the hypothesis is going to be s is the midpoint of rt, and the conclusion is going to be rs equals 1/2 rt. So this is the only time that it's switched. If is the only thing in there, then the conclusion comes first and the hypothesis comes second. And here's another one. This has only if. So the hypothesis is going to be angle 1 is congruent to angle 2, and our conclusion is the measure of angle 1 equals the measure of angle 2. And that's conditional statements, I believe. Yes, so now we're going to talk about counterexamples. So counterexamples are, if there's one example that does not follow what a conditional is saying, then the whole statement is false. This one example is called a counterexample. Now, there could be more than one, but if you find at least one counterexample, the whole statement is false. So for instance, if the windows are closed, then it is raining outside. So my hypothesis is the windows are closed. Okay, that has to be true. And right now, my windows are closed. So the windows are closed. that is my hypothesis. My conclusion is it's raining outside. Well, it's not. It's actually kind of sunny. So that is my counterexample. So this is a false statement. My counterexample is it's sunny and the windows are closed. So this is a false statement. That is my counterexample is it's sunny, or it's cold, or it's a tornado, or it's snowing, or anything like that, as long as I can find, if my hypothesis stays the same, but the conclusion is different, then it's a false statement. That's my counterexample. So if I can find a new conclusion, then that's a counterexample. So if we have if segment AB is congruent to segment BC, then B has to be the midpoint of segment AC. Well, that's not true. Because I can also draw a picture. So here, segment AB is congruent to segment BC, but B is not the midpoint of AC. So a diagram can also be a counterexample. Whatever you can do to say, hey, no, something else happens. If this is true and something else happens, that's your counterexample. If a line lies in a vertical plane, then the line is vertical. Well, this board is a vertical plane. Hey, look, there's a line in a vertical plane that is not vertical. Counterexample. If a number is divisible by 4, then it is divisible by 6. 16. 16 is divisible by 4, but it's not divisible by 6. Counterexample. X squared equals 49, x equals 7. This is a tricky one because that seems like the only value. X has to equal 7, right? No, x could equal negative 7. So negative 7 is the only counterexample for this conditional statement. And that's it. Cool.